Hello and welcome to your last set of notes in this unit before your test next week. We're going to do one more thing with vectors, and that's called the dot product. So if you haven't done the vector homework yet, please start with that. And if you were really confused by the vector homework, please nominate the questions you were stuck on in the form, or set up a Zoom appointment, send me an email, post something in the private comments, anything to let me know, because if you didn't understand the first lesson, we're going to keep going with vectors here. I want to make sure that you're on the same page. So the dot product is really helpful, especially in physics, because what the dot product tells us is it helps us find the angle between two vectors. So that's why it's important. So get yourself ready for notes, and I'm going to draw two vectors. Again, we're going to use V and U. And as I said, the dot product is really helpful because it finds the angle in between them. So I'm going to define V as x2, y2, and U as x1, y1. Now, there's two different formulas for the dot product. One that's going to be very straightforward and one that's going to feel much more complicated. That's all right. That's one of the reasons it's helpful. Now, both of these are based on the law of cosines. If you're interested, I will give you the formulas now. We call this U dot V. It's the dot product. And that is the simple way to find the dot product is you just multiply the x terms and the y terms. So we say x1, x2, plus y1, y2. Now here's the important thing, that this is not a vector. It will always just equal a number. So no vectors, just multiplication and addition. Now the other formula for the dot product, as I said, it's helpful to find the angle in between them, is you can take the magnitude of the two vectors multiplied by the cosine of theta. And the nice thing is, since these two are equal, we can often use this nice formula to find the dot product, and then the more complicated formula to find the angle. So what do I mean by that? I will show you. So given U is 7, 2, and V is negative 4, 0, find the dot product of U dot V. So I'm going to use the much easier formula to say U dot V, the x terms, 7 times negative 4, plus the y terms, 2 times 0. So a little bit of quick arithmetic. Negative 28, plus 0. The dot product of U dot V is equal to negative 28. So this is what I would generally recommend you do if it's just asking you to find the dot product. Now, if it's asking you to find the angle between the two, do this process first. Do this first. Once you've done this process, you can use this second formula. Because what it says here is that U dot V, right, is the magnitude of the two vectors times the cosine of the angle. Well, you already know that U dot V in this case is negative 28. That's what we just discovered. Now the magnitudes, I'm going to find over here. Magnitude of U is root 7 squared plus 2 squared, using the formula from the last lesson. So that would be root 49 plus 4, so that would be 53. And then magnitude of V is negative 4 squared plus 0 squared, which is root 16 plus 0, which is root 16, which is 4. So then I can plug those in and say negative 28 is equal to root 53 times 4 times cosine of theta. At this point, I probably divide both sides by 4. So I get negative 7 is equal to root 53 cosine theta. Divide both sides by root 53. So negative 7 over root 53 is equal to cosine theta. Then I will use my cosine inverse to say that theta is equal to cosine inverse of negative 7 over root 53. plug that into my calculator, and I will either get it in radians, if that's what my calculator is in, which would be 2.863 radians, or if I'm in degrees, that would be 164.055 degrees. So, if you're just looking for the dot product, use this nice easy formula. If it's asking for the angle, you're going to have to use both. One other way that we often ask about vectors is we want to know if they are orthogonal. Orthogonal is just a synonym for perpendicular. Perpendicular means that the angle in between them is equal to 90 degrees. So you can think that if I have u dot v, that's equal to the magnitudes times, if they're orthogonal, cosine of 90 degrees. Now, I hope you would remember is that cosine of 90 degrees is equal to 0. So magnitude times 0 just means if they are orthogonal, if their dot product is equal to 0. So you don't need to go through this whole process of finding the angle. You can just ask, well, is their dot product 0? So here, I'm going to jump straight to the dot product and ask myself, is it 0? So I've got 2 times negative 6 for the x components, and then y times 12 for my vertical components. So this is negative 12 plus 12. It's 0. So yes, these vectors are orthogonal. Please let me know if you're stuck on any of the ideas from chapters 6, 7, or 8. You'll have extended time on the quiz, both to allow for anyone who's doing MCA makeups and give you an opportunity to catch up on some of those missing assignments.